Let's talk about tangential and normal components of acceleration now. The definition says let RT be a vector-valued function that denotes the position of an object as a function of t. Then AT is equal to R double prime t is the acceleration vector. The tangential and normal components of acceleration AT and AN are given by the formula. So when I look at this AT here, AT is equal to the dot product of V and A over the magnitude of V. So if you think about this calculation altogether, this is a scalar here. Because when I do a dot product, I get a scalar, and when I do a magnitude, I get a scalar. So it's a scalar over a scalar, which gives me a scalar. And when I look at n here, A sub n, I'm taking a cross product of V and A, which is a vector, but then I'm taking the magnitude of that. So that tells me that's a scalar there. And the magnitude of V is also a scalar. So we're going to end up with a couple of scalars here, or scalar valued functions, when I talk about AT and AN. So my AT then is going to be V dot A over the magnitude of V. So we're just going to do that one first here when we actually do this problem at the bottom. And the second one is going to be our normal component of acceleration, the AN. All right, so what's nice about this, when I look at this, they say the components are related by the formula, and then that acceleration vector AT is actually equal to AT times vector t. Now t is a unit vector, so this is really the scalar. I should say, if I put those together, AT is the magnitude of that vector. And for the normal vector, AN is the scalar because n is also a unit vector. When I put those together, that's my acceleration vector, and that's my R double prime t. So what we're going to do here is we're going to find the tangential component first. We're just going to go in order of the formulas up top. That's why. No other reason. So I need a V, a and a magnitude of V. Okay, so I'm just going to find V first because V is actually equal to R prime t. And then when I look at my function here, it says for the function RT equals 2 or cos 2t, sine 2t, 1. So when I find the derivative of this, this is going to be negative 2 sine 2t for the first one. Now keep in mind here that when I do the derivative of cosine, it's negative sign. And this has a chain rule involved, the 2t inside. I have to take the derivative of that and times it by, and that's where this 2 in the front is coming from. Okay, so anyways, that's the first one. And the second one's going to have a similar instance there where I'm going to get that 2 as well. So that's going to be 2 cosine 2t, comma, and the derivative of 1 is 0. And now we need A, which is actually R double prime t. And that means I'm just going to take the derivative of this again. So then that's going to be negative 4 cosine 2t, comma, and this one here is going to be negative 4 sine 2t, comma, 0. And now I need the magnitude of V. So I'm going to get that from the top one here. Magnitude of V. Now keep in mind what that is. It's like I take each component, I square it, and then I add those together and I square root it. So that's what we're going to do now. So we're going to do the square root of, and I'm going to kind of do a few of these steps in my head. So this is going to be 4 sine squared 2t plus 4 cosine squared 2t. And then the 0 squared is just going to be 0. So that's really what I end up with. And now when I look at this here, this 4 sine squared theta plus 4 cosine squared theta. Now again, I didn't say 2t because I want you to see something here. I actually can pull a 4 out of both those terms there, and I would get sine squared 2t plus cosine squared 2t, which actually equals 1. So this actually equals 4 times 1 when we actually look at it for what it is, and this actually equals 2. So the vector v there, the magnitude of that is 2. So now let's take a look at the dot product then. So now we need v dot a. So when I look at that, I'm just going to write those vectors here. 2 sine of 2t, comma, 2 cosine of 2t, comma, 0, dotted, and then I have negative 4 cosine 2t, comma, negative 4 sine 2t, and then comma, 0. And then when I dot those together, a dot product works by multiplying the components together and then adding them. So we don't get a vector here. We just get either a real valued function or a scalar. So when I do the first one, a negative times a negative is positive, and then I get an 8. And that's going to be sine 2t cosine 2t. And then that's going to be plus. And then for the second one, I'm going to get a negative, because a positive and a negative is negative. So I'm going to get a negative 8. I meant the actual second ones. That threw me off for a second there. I did it for the first one again. But that's the one we're going to do, and that's going to be a negative times a positive is negative. So it's going to be negative 8 sine of 2t times cosine of 2t. And then for the last one, it's going to be plus 0. And I wrote that in there just for the sake of showing you all three of those pieces, just so you get a little more comfortable with the idea of dot product. Because, I don't know, for some reason that's easy to forget. Now, if you notice this, I have 8 sine 2t cos 2t, and minus, really a negative, 8 sine 2t cos 2t. And it's really plus a negative or a minus there. And that would actually be 0. So I actually get 0 here. So when I think of AT then, AT is just going to be that dot product on top, which is 0 over 2. And the 2 I got from the magnitude of V, and that actually gives me 0. So the tangential component of acceleration for RT is actually 0. So now we're going to need a lot more room, and we'll do this on the next page for the AN, or the normal component of acceleration. Now we're going to find the normal component, so I'll use a different color for that. So we're going to do the normal now. So if we look over here, let's see what we're going to need. We're going to need our V and A again, and we're going to need the magnitude of V. So we're just going to pull all that information from here. So V and A and the magnitude of V is what we're going to need here. So we're going to take all that, and we're going to put it over here. And that information, now we have when we need it. Okay, so the first thing we need now is we're going to have to take a cross product of V cross A. Okay, so we got to take V cross A. And our V vector, I'm just going to write those out for you. So here we go. We're going to do a cross product of V cross A now. I just cut and pasted the vectors from above. And we're going to just cover up the first. And we're going to have here 0 times 2 cosine 2t, which is 0, minus 0 times 4 sine, negative 4 sine 2t, which is 0. So for that first one, we're going to get equals 0. And then we got to negate the second one, it's plus, minus, plus. So now we're going to cover up the middle one here. And that's going to be 0 because we have these two here. 0 times this is 0, minus 0 times this, which is 0 as well. So that's also going to be 0. So I don't need the negative there, okay, because it's just 0. Now for the last one, we're going to cover up the third one now. So we're going to cover up these. Oops, excuse me. Okay, and then when we're looking at those, now we're going to have those two there. And we're going to cross them and multiply them. So that's going to be negative 8 or positive 8 sine squared t. 2t. Thank you. Okay, and then now we're going to, still covered, now we're going to take those two, and then that's going to be a negative 8. Oh, hang on. I messed up on my first one. This isn't a negative. I take my negative away. Oops. It's not negative, it's positive. I was just looking at it because a negative times a negative is positive for the first one. So it should be positive 8. Okay, and then the second one, it's minus here, but it's minus a negative 8. So it's really a plus 8 cosine squared 2t. Okay, now we got it together. And that's what the third one's going to be. So now cleaning this up a little bit, that's not a negative. That was actually a positive. I'm going to get rid of this negative sign. Constantly want to put negatives in there. I don't know why. Okay, because that negative times negative is positive for the first one. Okay, so now what we're going to do is we're going to simplify this a little bit. But if I pull an 8 out of the first, on the last one here, for each of the terms, that's going to be sine squared 2t plus cosine squared 2t. And this piece here equals 1. So we actually get 8 for the last component. So this actually equals, simplified, 0, 0, 8. Okay, so that's the V cross A. All right, now from here what we're going to do is we're going to go back to the formula. We found the top here, but now we have to take the magnitude of it to take it all the way. Okay, we need the magnitude of V cross A. Now that's going to be simple now because we have 0, 0, 8 for that. So V cross A, the magnitude of that. Now remember, we just take each of these components and square them, and sum them together and take the square root of that. So this is going to be the square root of, and I'll just write it out, plus 0 squared plus 8 squared, square rooted. So this is actually going to turn out to be 8. And that's V cross 8. Or V cross A, excuse me. Now we need the bottom there, which the bottom of this is the magnitude of V. And the magnitude of V we did in the first problem is 2. So this AN, oops, I should use a cap N since we're talking about a unit normal vector there. This is going to be V cross A over magnitude of V. So then that means we're going to get 8 over 2, which equals 4. So our normal component of acceleration is 4. So there's our 2 answers for this problem.